Hey everyone, this is No Smile John with Disruptive Weather, and today is Wednesday, February 18th, 2026. I've been trying to decide what I wanted to do my first video on, and so today I was just struggling to get good ideas, and so my phone popped up with a notification from an app of mine that counts my steps, and it said, walk some steps to get potentially some good ideas. And so I was like, maybe that's what I need to do. So I walked about 10 to 20 steps, and sure enough, everything just came to mind after walking that very, very short distance. So that all being said, it's early in the storm season at this point. The storm chase season in the Central Plains a lot of times really doesn't get going in full force until mid to late April. So with that being said, I decided to do a case study of a day that I chased several tornadoes, and that day is May 22nd, 2008. So if you can do the math, that means I was about 6 years old at the time, and I went chasing with a couple of my college friends at the time. So without further ado, let's go ahead and get started by looking at the event data first, and then we'll move on to the radar, and then we'll end with the video of the tornadoes. So first, I'd like to go ahead and give an overview of all the storm reports that came in that day. As you can see here, you had a lot of red, green, and blue dots. The red dots are tornado reports, green are hail reports, and blue are straight line wind reports. Kind of interesting, you do have a couple tornado reports out in California this day, along with a couple hail reports. But I won't be focusing on that. Just kind of interesting because they're not as common out there. They do still happen, but with less frequency. Also, up here in north central Colorado near the Wyoming border, there was a large tornado that hit the town of Windsor, Colorado. It was an F3, and it was moving from southeast to northwest, which is also kind of strange, but definitely can happen. The main focus of this case study is going to be the storm that I chased, which was in northwest Kansas, right around here. So when I'm looking at a setup for a given day, I typically, in the morning of, will look at the 300 millibar map. It's about 10 to 12 kilometers up above the surface. This is where the jet stream is typically found, and you can go look at it and get a good idea of the upper level pattern. Now, just a little backstory, we had actually been looking at the setup for this for 7 to 10 days on some of the computer models, and they started to come into full agreement probably around day 5, day 4. And so then the night before, we planned, after I got off work, to start heading up to southwest Kansas to get into position for the next day. So that was on the 21st. We got there around 3 a.m. to the hotel in Dodge City, and then we woke up the next day and started looking at the data. We probably woke up around 11. So anyway, here's the 12Z 300 millibar map, which again is up around 10 to 12 kilometers. And what you can see is a pattern that I'd like to refer to as a ski jump. We've seen these pretty frequently in big outbreaks in the plains, and this is fitting that pattern. If you look at this ski jump, a skier would probably not fare too well as they come down the ski jump and then come here. They would go straight up and then come right back down. So that would probably disrupt their skiing career for a while. Whereas a true ski jump would come and point more at a 45-degree angle or so. On that note, if you fast forward 12 hours from this time, it does look more like a ski jump, and it's pointed right out over this region. Just because the colors end here doesn't mean that the winds are not still very strong in this zone. You can see a 60, maybe 65 knot wind right there in Dodge City. And the other thing that's interesting here is the spreading out of the air as it comes out of the jet streak. You see right here in Wyoming, you have an east-southeast wind at this level, whereas over here in Omaha, you have a southwest wind. So the air is spreading out, or as we would call diffluence in meteorology. So moving down to a 500 millibar level, which is approximately 6 kilometers above the surface, What I'm looking for here is strong flow coming around over the region of interest. So you can see that you have pretty good flow, 55 knots in Amarillo, 35 in Dodge City. If you're not familiar with how to read these, I will put shorts together that cover each of the different things and how to read them. So stay tuned for that. But for the purpose of this, I'm just going to read off what it is. 35 knots from the south in Dodge City, 35 up in North Platte, Nebraska from the south-southwest. And the center of the 500 millibar low is over here in Utah. And again, this is at 12Z. Also, 12Z at this time of year is 7 a.m. So going down to 700 millibars, which is approximately 3 kilometers above the ground, you can see again that you have strong flow. That's the main thing I'm looking for in this map. We see the low out there near Utah again, and you see a 50 knot, almost southerly wind in Dodge City, and even in the surrounding areas, you see above 40. The next level that is really crucial for the development of tornadoes, and in particular strong tornadoes, is the real low level above surface winds. So maybe 500 meters to 1 kilometer up. Well, this is 850 millibars the morning of at 7 a.m. And this is basically giving us an idea that we have really strong flow at about 1 kilometer above the ground. And that's a good proxy for what the wind field is like in the near surface winds. So whether it's a kilometer up, 500 meters, 300 meters, it's a really good proxy. You can even go down to 925 millibars, but what you run into when you go down to 925 millibars is out here near Dodge City. The surface is above the 925 millibar level already. Therefore, you can see the winds in Oklahoma City and down here by Lawton, Oklahoma, but that's the winds we have. So that's why I usually go 850. And even out in Denver, you got to go 700 if you want to get a good idea. Okay, so moving on. Next, we're going to look at the surface observations. So this is what you actually are experiencing right at the surface. And I want to focus your attention to the region where we drove to, Dodge City. You can see right here we have a 61 dew point in Dodge City, a 59 out here west of Dodge City. That might be Garden City. And then you can see a 65 dew point. So you have some pretty good moisture, some upper 60 dew points. The green numbers are the dew points, red are the temperature. And then you can see analyzed here a warm front, which is moving northward. You can see on the north side of the warm front, though, we still have a 62, a 66 dew point, a 61 dew point. So this warm front is moving north, but even the air north of it for a good distance still has good dew point air to work with. So what I'm going to do next is just move forward every 3 hours. So this time right here is at 1 p.m. This is about when storms were starting to initiate on the dry line right here. So you can see a dry line analyzed right here. You can see ahead of it, you see some 50 dew points, a 61, a 59, and some 80-degree temperatures in the 80s. Behind it, you can see how the dew points are much, much lower. So it's really dry to the west of it. And the winds also commonly shift with the passage of a dry line or being on one side versus the other. Usually, typically ahead of it, you'll see air that's a little bit cooler and moist. Now, that doesn't mean it's cold. It's just cooler than what you would typically find on the west side. And as we go forward to the next 3 hours, you can see west of it, you have a 91 and 88 here. So you can see warmer air west of it. Then you have the cold front immediately west of that. So you have a very narrow region of warmer, dry air before the cold front that's analyzed here. But meanwhile, the warm front, let me just show that again, the warm front has progressed northward a little bit in the last 3 hours. And then by 7 p.m., it's now up here, which this is pretty close to I-70. Again, you can still see north of the front, you see 62, 61, 62. That's still good moisture. So what we're going to look at next is the moisture, just to give you a better idea of the moisture in the morning of at 7 a.m. And then if you just loop through this, you can see how it it's moving northward with time. The first green contour right here is 60. So that's a 60-degree dew point. You can see that's consistent with the map we just looked at before with a 60-degree dew point going all the way up to the Nebraska-Kansas border. So what this is showing is at 4 p.m., the red is a measure of instability. So if you see a number 4,000, that's larger than, say, over here where it's 3,000. But 3,000 is really good. Heck, there have been days where you see tornadoes with 1 to 200 cape. This is 4,000 cape. So this is really extreme instability all the way up to this location right here, which is where the warm front is. And then you can go forward another hour, you can see that the cap has eroded. The blue is the cap. So the light blue is a weaker cap, the dark blue is a stronger cap. So this whole region here is now uncapped all the way up to the Colorado, Nebraska, Kansas intersection. And so the key is the storms actually fire down here in southwest Kansas, and we'll see that on radar here. And so once you have a storm that's going really well, it can sometimes stay together for a long time, even in a capped environment. It's just getting it to initiate. You're going to need the cap to be eroded away. But again, sometimes if you have a weakly capped environment, you can sometimes have storms that still sustain themselves and keep going. Um, but if you have a really strong cap, they can eventually get cut off and from the surface and become elevated storms, which basically takes away the tornado opportunities. So that's the surface cape, which is the instability measurement, and the cap. Okay, this map here is at 6 p.m. And this is approximately when the storm we're on is doing a lot of its tornadoes right in this zone where you can see the really higher numbers. So what this higher number is called a significant tornado parameter. And the higher the significant tornado parameter, the more favorable your environment is for significant tornadoes. So traditionally, most significant tornadoes, based on the research done, you want a value that's above 1. As you can see, we have values in the 3 to 4 range in northwest Kansas here. So definitely above 1 by a good amount. Okay, so given all this information, what I want to look at next is the Storm Prediction Center's outlook for the day. So the Storm Prediction Center, they issue outlooks for the region for the United States every day of the year. Now, a lot of days that equals not much at all. So for the outlook on this day, the Storm Prediction Center at 3 p.m. Before this, they had a moderate risk, but as you can see here, they have a high risk in that zone where we were targeting and chasing. So the categorical outlook is high risk. But then down here, you can see the tornado probabilities, and they have 30% chance of a tornado occurring within 25 miles of any point. The hatched area, which is this light blue with all the hatching going across it, that is 10% or greater probability of EF2 to EF5, so strong tornadoes. And then they have damaging wind probability, that's straight line wind, and then hail. You can see large hail is definitely in the cards for this day. Okay, so now we're going to take a look at the radar for this day. As I mentioned earlier, we stayed the night in Dodge City. Storms started to initiate relatively early, maybe around 1 to 2 o'clock along the dry line, and you can see the dry line right there on the Goodland radar. This is all Goodland's radar. And so we drove west from Dodge City and we got on this storm right here. There were storms up here to the north, but since these were moving northeastward at 45 miles per hour, we were unable to even have a chance at catching up with those two storms. But they look really decent. Now I'm going to zoom in here and I'm just going to step through, and you can see how just about 30, 45 minutes later, our storm is kind of the smallest one out of the three down here. You got this one that's pretty big. This one's pretty big. Even the one up here by Gove is pretty big. And that one has a hook on it, so it's looking really good. A uh, large reflectivity, likely indicative of hail. This one had a tornado warning, and I believe also produced some decent sized tornadoes up in this region. So I'm just going to play it. Okay, so that's where we were. And so we're still going with this storm. We haven't seen any tornadoes yet. I'm going to zoom in a little bit more. But we saw this storm earlier that had tornadoes with it up in this region. So up by I-70, that's this blue line, all the way up to the Nebraska border. You can see it was tornadoing up kind of in this zone. And we were thinking, hey, well, maybe there's something favorable in that area. Like if you recall the surface winds, there was that warm front here, and surface winds were from the east north of the warm front. So maybe once this storm crosses that warm front into the easterly winds, maybe it might get its act together and start producing a tornado. So that's what we were banking on. And we kept following this storm, knowing that if this storm doesn't do anything, we could always drop south to the next one. Alternatively, we couldn't drop south to this one and then hope to come back to this one if this one started going because we would not be able to catch it. So we stuck with this one. So we kept following it, and right about the time it got to Gove or just north of Gove, that's when it started to produce its first tornado. And we call it the Grainfield tornado because that was the closest town. And that was a nice elephant trunk tornado. It lasted for maybe 10 minutes and then it lifted. It might have actually lasted longer than 10 minutes. It might have been more like 15 to 20. But while it was weakening, a new tornado was touching down closer to us while the other one's off in the distance. And you'll see that in the video here momentarily. The new tornado that touched down closer to us ended up being a large tornado that tracked on the west side of the town of Hoxie. It didn't hit anything, so thankfully it was just out in open country. Then that one lifted, and I'm going to zoom in here and kind of give you a point of reference of where we were. So we were at this T intersection looking south at this time. We got ahead of the storm and the Hoxie tornado had lifted and a new one was starting to form. And we actually saw two weak tornadoes right here while it was getting organized. And then we drove east on this road and then went north to Dresden, this is when it was getting really better organized from here all the way up to almost the Nebraska borders where it put down its largest tornado, and you'll see that in the video. But as you loop forward, you can see how the hook is really well defined there now. Um, and you can see the warm inflow right in this area where you don't have any reflectivity. Okay, so here you can see the first tornado starting to form. I don't know what that is, if it's dust or just condensation. I'm guessing there's a good chance it may just be cow pies because this is western Kansas where there's a lot of cattle farms. So can see that all that dust, as I like to call it, cow pies, getting sucked up into the circulation and it starts to rotate as it gets sucked up, and you can see the funnel of the tornado. Jumping ahead, I mentioned it evolves into an elephant trunk tornado. Very nice, well-defined tornado. And then it lifts, and you can see that's the original tornado off in the distance back there, and here's the new one forming. This ends up becoming the Hoxie tornado. So going forward here is when it becomes the Hoxie tornado. And you can see that is a very large tornado. Again, luckily this is out over open country, so not many lives are being disrupted by this tornado. Jumping forward, here's where we are at that T intersection I showed you with the two smaller tornadoes. But as time goes on, it starts to get its act together and become a really big tornado. So I'll fast forward. So right here, it's west of the road we're on, but it's moving north-northeast, so it has a little bit of an easterly component that brings it closer to the road with time. And eventually it'll be right behind us on the road. It's moving north at 45. We're moving north at 65. One thing I want you to see here is the multiple vortices. You can see them right there. Let me jump forward. You can see another couple right. Let me back it up a little. You can see another couple multiple vortices form right there. There were a lot of vortices. Those are just a few of the more impressive ones that we saw. Here's the tornado getting better and better organized. Here it is when it's on the about to be on the road behind us. You can see how rapid the circulation is of the clouds going around it. And there it is on the road behind us. Now, I'm going to fast forward a little bit more to where it is coming toward the town of Dresden. If you remember, Dresden is where we turned right on an east road so that we can let this pass us. North of this road, there wasn't a very good road network. It was very rural, not much out there. And so luckily this tornado, as it crossed the road and got past Dresden, did not really hit much, so it didn't do a lot of disruption of lives and damage. One thing that's interesting here, you can see the condensation denoted by the dark cloud lifts as it goes over Dresden, but that does not mean that the tornado has lifted. It just means the condensation funnel has lifted, but you can still see lots of debris and dust and maybe more cow pies getting blown around down at the ground there as it's near Dresden. But after it crosses the road, it starts to get its act together again and puts the condensation back down to the ground, and it becomes a really large tornado at this point. The biggest tornado of the day. Unfortunately, we can't keep up with it because of the road network. But as you can see, it's out here in a rural part of Kansas, so it's probably just killing a bunch of mosquitoes. So there, the mosquito population there was definitely disrupted. Um, on that note, let's pause it, take a moment of silence for all those dead mosquitoes. Okay, so this was the May 22nd, 2008 tornado outbreak. There were so many tornadoes this day, and this was just the beginning of a 5 day stretch of tornado days that produced tornadoes, and including an F5 that occurred, EF5 that occurred up in Parkersburg, Iowa, just 3 days after this one. That concludes the case study of May 22nd, 2008. If you like this video, please click the like button, and also please click the subscribe button at the bottom. That way you'll be notified when I release new videos. Thank you and have a great evening.